Uh, Today I'm going to show you how you can use L'Hopital's rule to determine the value of this limit, which has quite an interesting result. So naturally, when you're trying to do a limit, you'd probably just start by seeing what happened if you plugged in the limit. So yep, let's do that. So we would have, obviously this is just like kind of rough if we were trying to figure this out. Okay, so this would tend to 0. Which would leave us with 1 to the infinity, which is like an indeterminate form. This doesn't really help us, so we're going to have to somehow change the limit to a different form where we can actually figure out what the limit comes to. So let's do that. The way I'm going to do that is by um, rewriting this as e to the natural log of 1 plus 1 over n, and this is to the n, so this is exactly equivalent, because obviously natural log is the inverse of the exponential, so this is actually going to allow us to bring this power inside using like normal power exponent rules. So let's do that. So we're going to have e to the n times the natural log of 1 plus 1 over n. Okay. Maybe this has helped us find a way to express this limit as a finite number. Let's see, let's try plugging infinity in again. So we're going to have e to the infinity times by a log of 1. So that's just going to be 0. So we're basically left with another indeterminate form, which is infinity times 0. So we're going to have to do something more in order to find out the value of the limit. Okay. Since the exponential function is continuous, I'm just going to move the limit inside the function, and then we'll just determine that limit and then plug it back in. And yeah, so n times log of 1 plus 1 over n. Okay, so our goal here is to determine this limit. Let's do that. I won't use an equal sign because it's not really equivalent anymore, but let's find out what that limit is. I'll just draw like an arrow. So basically we want to use L'Hopital's rule. So we're going to rewrite this in a way where we can use that. We're going to rewrite it as the log of 1 plus 1 over n divided by 1 over n, which is equivalent to, this is exactly equivalent, so to the limit we were trying to find before. Okay, so let's see what this gives us. So this will give us the top is going to give us 0, and 1 over n to the as n goes to infinity is also 0. So this is going to give us 0 over 0, which is actually this is the main condition that we need to use L'Hopital's rule. So let's do that. L'Hopital's rule states that if a limit of the quotient of two functions tends to 0 over 0, then if the limit of the quotient of their derivatives exists or is infinity, then they're equal. So yeah, let's do that. Let's use L'Hopital's rule. So we have to differentiate the top. So it's going to give us 1 over 1 plus n standard derivative, and then we have to use the chain rule. So we have to multiply this by the derivative of what's inside the brackets, which is going to give us minus 1 over n squared, and then the the derivative of the denominator is just the exact same thing. So yeah. Okay, so I should really write the limit here if I want to use the equal sign. Okay, so we can see that these are just going to cancel out, and we're just left with the limit as n tends to infinity of 1 over 1 plus 1 over n. And this is not indeterminate anymore. This is, this is going to give us 1. So that's pretty cool. So we should plug this limit back into here. So we're going to get that this limit is this entire limit is equal to e to the 1, which is obviously just e. Okay, so that's pretty cool. So now let's just write out what we figured out here. So we've determined that the limit as n tends to infinity of 1 plus 1 over n to the n equals e. So that's pretty cool, right? You know, this is like a limit definition of e, which is like an irrational number, and it's also, it's a pretty cool number. So yeah, thanks for watching, I guess. Thank you.